What if I tell you that 75% of data science projects fail not because of lack of technical skills or bad models, but because of poor data understanding? In this video, I'll show you how a clear understanding of business data enables you to ask the right set of business questions and can save you from this trap. Hey there, welcome to the next video in this section, one of the most important video in this course. Let's start by discussing the agenda of this video. The very first thing I'll show you is different ways to import data into Google Sheets. Next, since our data is tabular, it means structured in rows and columns, we will explore key data terminologies which are commonly used in data science. After that, we'll spend a good amount of time thoroughly understanding the superstore sales data, examining every aspect of this business dataset. Once we are familiar with the data, we will explore critical business questions that stakeholders and decision makers expect us to answer. Then we will deep dive into an important technical concept called data granularity, also known as level of detail in a dataset. Then I'll demonstrate you how to import the sales data into Tableau and give you a guided walkthrough of Tableau's interface. Finally, we will wrap up the discussion by understanding data types both in Tableau and in general data science applications. Cool. As I already told you before, this is one of the most important video in this course. The concept we cover, data terminologies, understanding business needs, data granularity, and data types, these will form the foundation of your analytical skill set. So without further ado, let's jump into Google Sheets and start by importing the sales data. Before we start importing the sales data, let's create a blank spreadsheet. So the first way is through Google Drive. Head over to your Google Drive's homepage and open the folder where you want to save the file. For me, I've created a folder called Spreadsheet Files. This is the folder in which I'm going to save all of my spreadsheets that I'll create. Let's go inside this folder. Once inside, right-click and hover over Google Sheets and click to create a new file. There you go, a brand new spreadsheet is created. So let's rename it to First Sheet so that we can keep things organized. Click on this untitled spreadsheet to rename the file. Let's rename it to First Sheet and hit enter. Now our first sheet is created and it is saved into its respective folder. So this was the first method of creating a blank spreadsheet. Now what if you don't want to go through Google Drive? No problem. Just open a new Chrome tab and search for Google Sheets. Click on the first link and the blank spreadsheet is created. Let's rename it to Second Sheet. Now here's a little catch. Since we didn't pick a folder for this sheet, Google saves it in the root folder of your drive. Let's see what do I mean by this. Go to your Google Drive's homepage and see where this file Second Sheet is located. So click on My Drive and see this second sheet is located on the homepage itself. Now the task is to put the sheet into its right folder. No worries though, to save it in the desired folder, go to the sheet and adjacent to the sheet name, you can see this little icon which is to move the file. Click on this move button and choose the folder where you want to move this file. And now a file is moved to the spreadsheet files folder. It's that simple. Now let's go and check it out whether a file has moved into its desired folder or not. Click on the folder and see both the sheets are in its respective folder. So this is how you create blank sheets and save it into the desired folder. Now let's get serious. Since we are going to work with actual data, let's create a dedicated sheet for that. Go to the spreadsheet files folder again. Once in the right folder, right click again and click on Google Sheets. And this time, let's rename it to Superstore Sales Data and hit enter. Awesome. Now that we have a blank spreadsheet ready, let's import sales data and start understanding it. Alright, let me first walk you through how our data files looks like offline in Microsoft Excel before we bring it into Google Sheets. I have the data file on my desktop, so let's quickly open it. So here's the data. This is a publicly available dataset for our learning purpose. It has around 10,000 rows and 20 columns. Yep, that's a lot of data. But don't worry, we'll break it down step by step. First thing, I want you to look at the bottom of this file. You'll see there are 3 sheets in this file. Think of this entire Excel file as a mini database because it holds different types of related data in separate sheets. So we are already in this first sheet, and the name of this sheet is Orders sheet. This first sheet has sales data in it. This is where we have the actual transactional details like order date, shipping information, customer demographics, product categories, and financial numbers such as sales, quantity, discount, and profit. Don't stress about all these details right now. We'll go through them in the next 5 minutes and understand what's important. Now let's click on the second sheet, which is unique returns, and see what type of data this sheet contains. This one keeps track of whether an order was returned or not. A particular order is identified by its order ID, and if an order was return order, we have marked it at yes. This sort of data will help us analyze the refund trends and figure out which product or customers have the highest return rates. The third sheet has simple but important data in it. This sheet contains the names of regional managers responsible for different stores. When we start analyzing sales performance by region, this data will be super helpful. Alright, now that we have seen the data offline and have our Google Sheet ready, let's import the data from the desktop to this Google Sheet. I'll show you two super easy ways to do it. So the first method is importing directly from your offline desktop folder. Open the Google Sheet in which you want to import the data. For us, it is Superstore sales data file. Click on File and select Import. Select the Upload tab and hit Browse. Navigate to your desktop folder and select the Excel file and click Open. Wait for a few seconds. If your file is big, let's say more than 50 MBs, it might take a minute or two. So no need to panic over here. In our case, it's just 1 to 2 MBs, so it's a quick upload. Once the upload is complete, from the drop-down menu, select Insert New Sheets. Click Import Data and boom, all three sheets are now inside our Google Sheet. Alright, let's check out another way to import data. This time we'll do it directly from Google Drive instead from the desktop folder. But first, let's clear out the sheets we just imported so we can start fresh. I'll select all the sheets one by one and delete them. To select all of them in one go, you can press the Ctrl button and keep selecting and then right click to delete the sheets. It will show you the warning. Are you sure you want to delete all three sheets? Click OK and see all these sheets that we have imported are now gone. Now for the second method, let's upload the file to Google Drive first before importing it into our spreadsheet. Let's head to the Google Drive first and go to the parent folder and select the folder in which you want to upload the data. I have created this data folder in my drive to upload and save all data files for our course. Let's go inside this folder to upload the file from desktop. First, click on New and then click on File Upload. Select your desktop folder and locate your file to be uploaded and click Open. This will start uploading the Superstore sales data into the folder. Now once uploaded successfully, go to a blank spreadsheet again. Go to File, select Import. This time select My Drive instead of Upload and double click on the data folder. Select the newly uploaded data and click Insert. Again from the drop down, select Insert New Sheets and click Import Data to insert all three sheets here itself. And within few seconds, all three sheets are imported successfully. Alright, now that we have our data imported, let's clean up the formatting a bit to make it more readable. Notice how some column names like order date and country region are wrapped up, making them little hard to read and understand. Let's fix that. Click on the top left rectangle where rows and column headers intersect. This will select the entire sheet. Then go to the text wrapping in the Quick Access toolbar. This toolbar is called the Quick Access toolbar. Go to text wrapping and select the overflow. See the difference? Now the column names are properly displayed without taking up extra space. But even after unwrapping, some column names might still be cut off. For example, this order date, country and region, postal code, which is not completely displayed. So let's fix that too. For this, we might want to adjust the column width. Again, select the complete sheet by clicking on this rectangle and hover over the border between column A and column B. When you see this resize cursor, double click on it and boom, the column width adjusts automatically to fit the text perfectly. So this is how you deal with the basic aesthetics of your Google Sheets. Alright, now let's check how many columns and rows we actually have in this dataset. First, click on the cell A1. Notice how the cell address appears in the left top box. To select all the column names, it means all the horizontal cells till we have continuous data, I will use the keyboard shortcut Command Shift and right arrow. It will select all the columns. I'm using MacBook here, but for Windows users, instead of Command, press Ctrl plus Shift plus right arrow. The shortcut keys combination for both Windows and Mac are displayed on the screen to avoid any confusion. So this is how you select all the column names in your dataset. Now how do I know that there are 20 columns in this dataset? Notice the count at the right bottom in the status bar. This tells us that we have 20 columns in this data. In the similar manner, go to A1 cell again and select all rows. The shortcut to select all the data vertically is displayed on the screen. Notice the count at the right bottom again. This tells us that we have 9995 rows in the data. The first row contains the column names, therefore in reality we have 9994 rows worth of data in the sheet. Now let me quickly show you the power of this status bar that tells us the number of columns and rows in the data. It appears at the right bottom of the screen when we select multiple cells. To demonstrate this ability of the status bar, let's navigate to the sales column. Remember, the sales figures are in US dollars. Now what if I select all the data in this column? Instantly, the Excel provides key statistics right on the status bar. By default, I can see the total sum, which is approximately $2.29 million. But that's not all. By clicking on the status bar, lets you access even more insights, like what is the minimum sales, what is the maximum sales, what is the average of the sales, and count, which tells us the number of cells that have numerical data in it. And all that without using a single formula. Pretty cool stuff, right? Now before telling you more basic but super important stuff, let me pose a question in front of you. Let's say you want to analyze total sales not in dollars but in Indian rupees instead. What will you do? This sort of stuff you will be doing almost every time when you do data analysis in Excel. So let's see what do I mean by it. Instead of this dollar value, I want to know sales values in Indian rupees or INR. Let me first search for the latest USD to INR conversion on Google itself. Open a new Chrome tab and select for USD to INR. Let's use $1 equals to 86 INR as conversion rate. Now let's go back to our Superstore sales data. So essentially, I want to create a new column and name this as sales in INR. Let me insert a new column to the right of it so that we have some little breathing space. So right click on this column and select insert one column to right. And you see one new column has been inserted over here. I can again resize this column. Now I need to populate this column with its corresponding sale value in INR. For example, the value of sale 261.96, I need to multiply it with 86 and put the final value in this cell. Let's do this using vanilla multiplication formula. Can I write 261.96 multiplied by 86 and hit enter? Yes, I can, but nothing happens, right? Since this should be a formula or a math equation, I need to put a equal sign in front of the calculation to observe the desired result. So let's go ahead and put the equal sign in front of it. Now you see all the color schemes has changed, and this time Excel is telling me that this is a formula now. So if we hit enter and let's cross this autofill suggestion, and you see total sales value of $262 is now being converted into the Indian rupees, which is around 22k. But did you notice something strange over here? Let me double click on this. I am manually inserting this 261.96, but we don't need to do this. So rather than typing the exact value, I can provide the address of the cell where this value is located. It means 261.96 is located at this particular cell. We need to figure out the address of this cell. We can put the address of this cell over here instead of 261.96. If I click on 261.96, you see the address of this cell is Q2. It means it is in the Qth column and second row. Double click on this formula again, and instead of 261.96, type Q2. As soon as we finish typing Q2, the Excel has referenced to this value 261.96 just by the address of it, and hit enter. Now that we have computed this for one cell, let's autofill by double clicking on the computed cells bottom right corner over here. Just double click, the cell value in INR is auto populated in the rest of the cells. Great! This was one of the easiest way to create a calculated field or new column using a basic formula. Now that we have understood the structure of the data, this type of structured data is called tabular dataset because it is organized in tables of rows and columns. And there are many terminologies associated with it that we need to understand as data analyst or data scientist. Let's discuss these terminologies in greater detail. So now you know what exactly is a dataset. Think of it like a giant Excel or Google Sheet tables which contains information arranged in rows and columns. Look at this table on the screen. This dataset about 5 different people represent some attributes like ID, name, gender, age, height, weight and hair color. Here each row contains data about a single person. For example, this row 1 belongs to Alice's details. Row 2 is exclusively for Bob's details, and so on. Each row is also known as a data point, an observation, a record or an entry. Also, each column holds one specific type of information about all individuals, right? For example, the name column contains names of all people. The age column holds their ages. Similarly, the height column contains the height value in centimeters for everyone. Each column is also known as attribute or variable, a feature, field or header. I'll keep using these terms interchangeably throughout the course, so do take note of these different names. Now if I ask you how many attributes or column are there in this dataset, we can easily count and you should say 7. And if I ask how many data points or rows are there in this dataset, you should say 5. We usually represent rows by smaller letter m and columns by small letter n. And the notation we use to describe the shape of this dataset is either rows, column, which is m, n, here it is 5, 7, or rows cross column, which is m cross n, which is 5 cross 7. I hope these basic notation as well as these terminologies are crystal clear to you now. Keeping these simple concepts in mind, let's start delving into real sales data and understand every nuance of it. Alright, let's first understand the journey of a single order. This is a crucial slide, so pay close attention. If anything is unclear, please rewatch this part before moving forward. Imagine you are placing an order from this superstore. Would it be correct to say that you must have created a profile on this e-commerce platform before making a purchase, right? Now since you are a unique customer, the superstore assigns you a unique customer ID. Along with this ID, it stores your name, consumer segment, whether you are an individual consumer or a corporate, your country, city, state, postal code, and the region you belong to. For example, it may be east, west, north, or south. Now you add a few items to the cart and place an order. A unique order ID will be generated for this order, along with additional details such as order date, ship date, and ship mode. I hope this much is pretty clear. Now what we are missing? Think about it. Yes, the details about the individual product and the order's monetary value. Let's first look at the product or item details. Let's assume the first item in your order is a great looking smartwatch that you ordered for your loved ones. Since this product is a part of store's inventory, the business already has a stored information about it. It's usually the unique product ID, the product name, category, and the subcategory of the product. In a dataset, we have three categories, namely furniture, office supplies, and technology. So in this case, the category could be technology and the subcategory could be watches. Cool. Similarly, the next item you have in your cart could be some stationery and a sofa. And the similar details about this product are also stored by the business. Now coming to the dollar value of each product. The business usually keeps track of the financial variables like sales value, quantity ordered, any discount applied, and the profit earned on each product. Pause the video for a moment and take a close look at this schema and think, if you were to store this order information in a tabular format based on everything we just discussed, how many rows and columns you would need to capture all data in a structured table? Exactly. Since you ordered 3 different products, a smartwatch, a stationery and a sofa, each product needs a separate row to store its details. And apart from the header row, which contains the column names, we would need 3 rows to record this order properly. And since our dataset has 20 columns, all these details will be stored across these columns. Perfect. Now let's take a look at the actual sales data snapshot. Notice how order number 112326 follows the same structure we just discussed. It takes up 3 rows, one for each product in that order. The order ID stays same across these rows because they belong to the same transaction. However, the product ID, product name, sales, quantity, discount, and profit values differ for each row since they represent different products. So this is how business track sales at granular level. Each row represents a single product within an order, while the order itself can span multiple rows. So the key takeaway here is that a single order can span multiple rows in the dataset, one row for each product included in that order. If this concept isn't crystal clear yet, I highly recommend pausing the video and taking a moment to carefully observe this slide. Try to spot the pattern in how orders are structured in this dataset. Once you're confident, then only move ahead. Also notice how I have color-coded the column names to match the flow as we just discussed. This makes it much easier to understand. All the order-related features are displayed in blue color. Customer details are in gray color. Similarly, product details are in yellow, and the monetary value like sales, profit, and discount are in green shade. This is exactly how you should study a dataset, by categorizing the information to get a clear picture of the business before diving into the analysis. Now that we've understood the data structure, it's time to shift our focus to key business questions that need answers. Let's move on to the next slide, business expectations. This is where we will explore what insights the business wants to gain from this data and take important decisions based on the analysis. Here we will deep dive into business perspective, understanding the pain points, and here I'll help you acquire basics of business acumen to figure out how to ask the right set of questions to the data. This discussion will train your mind to think like a business analyst, identifying key challenges and extracting meaningful insights. Here's the snapshot of data we just discussed, keeping it handy for reference. Let's break it down step by step. Firstly, what insights does the business wants from us? And why does the business need specific analysis, and how will the business implement these insights in real-world decision making? Once we clearly understand the business ask and the potential outcome they seek, the next step is to drill into the data and identify exactly which columns or variables we will use for our analysis. This step is crucial because having a clear mapping between the business questions and the relevant data fields ensures that our analysis is focused, efficient, and aligned with the business goals. Let's go one by one. First insight the business may want us to figure out is what are the top selling products and categories. And as per the findings, business may stock more of bestsellers and improve supply chain for high demand products. Now from the question itself, try to figure out which columns or data subset will be helpful for this analysis. Pause the video and write down all the column names you think are needed. Don't rush, this step is super important. Cool, since we are looking for best selling products, so we need fields related to products, especially product name, category, and subcategory, and the numerical fields such as sales and quantity. Here I tried to give you a simple framework to identify the right data for your analysis. This is a non-negotiable skill that every data analyst must develop early in their career. It is also called business acumen, which means how well you understand the business context and what matters the most. All the technical implementation comes later. Great, now let's move on to the rest of the questions and apply this framework one by one. Keep staring at the question until you are super clear about the business needs. After analyzing top sellers, let's now look at most profitable products and subcategories. This type of analysis is critical for business because they may want to prioritize marketing for high margin products and may want to adjust pricing for low profit items. Since this time we are analyzing the profitability, so we definitely need the profit column and the rest of the column regarding the product details. Super easy, right? The next one is interesting. Now the business wants you to perform customer segment analysis. Let me quickly tell you what is customer segmentation and why it is important. Have you ever received phone calls from banks offering loans or credit cards? Yes? Now think about it. Are they calling every single customer in the database? Of course not. A bank might have millions of customers. So how they decide who to target? So they must have identified patterns in the customer base to figure out who is most likely to be interested in a loan or credit product. This type of analysis is called customer segmentation analysis, where they identify segments of customers who are likely to respond to their marketing campaigns. Businesses use it to personalize promotions and create sales strategies tailored to specific customer groups. Now for a moment, think about potential variables you might need for this analysis. Exactly. For this analysis, we must focus on customer-related features. Here's the field we will definitely require. We need customer ID to identify unique customers, customer name mainly for reference, segment to classify customer into consumer, corporate or home office. We might need region to basically analyze geographical distribution of these customer segments. And finally, sales and profit to measure their spending and profitability. I've listed a few key variables here, but feel free to add more based on the insights you want to extract. The next question we'll tackle is analyzing region-wise sales distribution. This is essential because businesses aim to focus their efforts strategically, maximizing opportunities in high-performing regions while developing targeted strategies for underperforming ones. Again, take a moment to think about what sort of variables you need for this analysis. Variables related to geography, such as region, state, and city, are a must. And we also need sales and profit to quantify performance. The next question we'll explore is assessing the impact of discount on sales and profit. It is a crucial analysis because offering too much discount can lead to losses, while offering too little might hurt overall sales. The goal is to find the right balance to maximize revenue without compromising profitability. Again, the variables we might require are related to product category, maybe subcategory, and numerical fields such as discount, sales, and profit. Now, if the business is more mature or they have good amount of historical data, they may want to conduct a new customer versus repeat customer analysis. The purpose of this is to design loyalty programs for returning customers while crafting effective acquisition strategies to attract new buyers. Think about the key variables needed for this analysis. When we talk about new versus repeat customers, we are essentially looking at when a customer made a purchase on the platform. So we'll definitely need order date to track purchase history, customer details, namely customer ID and customer name, and also sales to analyze revenue generated by each customer. Again, feel free to add more variables as needed as per the analysis requirement. Now let's analyze which product and categories are likely to see higher sales during special occasions like Black Friday, Christmas, New Year, or maybe seasons like in summers and winters. To identify these trends, the business wants you to conduct a seasonality and trend analysis. The The primary objective is to optimize stock levels to efficiently meet peak demand periods. For this analysis, the historical data you will need is order date, sales, category and subcategory, and possibly product details as well. Alright, now the business may want to optimize its operational efficiency by minimizing order processing times. To identify areas of improvement, you need to analyze how efficiently each order is being fulfilled to the customer. This will help optimize logistics and ultimately help in improving the customer satisfaction metrics. The variables you might need are mostly order-specific variables, namely order date, ship date, and shipping mode. Now what if the company is overspending on shipping? We can analyze the shipping mode and its contribution to sales and profit to identify cost-effective shipping methods for different order types. So the key variables required for this analysis may include shipping mode, sales, and profit values. So these are some of the questions you as an analyst may be asked to work on. The crucial part is to thoroughly understand the question and the business objective behind it. Once you are aligned with the final goal, you can confidently proceed with the analysis. Now the next step is to determine the solution approach and choose the right tools to present your findings. This is where Excel and Tableau comes into the play. I'll guide you in developing the aptitude to structure a solution approach, followed by the technical implementation to create impactful visualizations that effectively communicate these insights. Finally, we'll bring all these insights and visualizations together in a beautiful dynamic dashboard, enabling top management and stakeholders to monitor key performance indicators effortlessly and make data-driven decisions within just few clicks. Sounds great, right? Awesome. Now is the perfect moment to dive into few more technical aspects. The next key concept we'll understand is data granularity, which is also known as level of detail. The granularity of the data table refers to the level of detail at which the data is recorded. Sounds technical, right? Let's look at the sales data and break it down step by step to understand what I just mentioned. Now, we understand that a single order contains multiple products. For example, this order ID 152156 contains 2 products. Now the question is, can we uniquely identify a row using only the order ID? No, we cannot, because the same order ID appears multiple times for different products in that single order. What if we look at both order ID and product ID together? Yes, now we see a row becomes unique. Think about it, right? So the level of detail or granularity of this data table is at the order product level. Let me repeat. The level of detail or the granularity of this data table is at the order product level. Let's name this full data table as table 1 and put everything I just mentioned in the text here. So we discussed that granularity refers to the level of detail or the level of table. That means at what level the data is stored in the table. So this table 1 is at the order ID and product ID level or the order product level. Therefore, the granularity of table 1 is at the order product level. Next, let's do a small exercise. I'll identify the unique categories from this main table 1. We can quickly go to the data table and use the filter function. Put your cursor on this category cell and go to the quick access toolbar and click on the create a filter. And then clicking on this filter option right to the category will display the unique categories that we have in our dataset. So these are furniture, office supplies, and technology. This is a quick way to check unique values in a column in the spreadsheet. Now that we know that we have 3 unique categories, either it's furniture, office supplies, or technology, the next thing I want to calculate the total sales of each category and organize them into a different table. Let's see, what do I mean by this? Here I have aggregated the sales at the category level by summing up the sales values and named it as table 2. Even though this table 2 is derived from table 1, the granularity of this table is at the category level only. Because in this table, we can uniquely identify each row only by the category itself. So the key takeaway here is that Data aggregation lowered the granularity by summarizing the information. I hope this is all coming together for you. Now let's make this more interesting. Instead of aggregating only at category level, what if we sum the sales both at the category and subcategory levels? This is exactly what I have done in the table 3. Now think about it. As compared to table 2, have we increased or reduced the granularity? If you believe the granularity has increased, then you are absolutely right. Finally, here's a simple quiz for you. Can you determine the final granularity order of all 3 tables? Pause the video for a few seconds and write down the correct order for me. Now let me reveal the correct order of granularity. Table 2 has the least granularity since it summarizes the data only at the category level. Moving on to the table 3, the granularity increases as it provides details at both the category and subcategory level. Finally, the table 1 holds the highest level of granularity as it contains data at the order ID and product ID level, which captures the most detailed information. Cool. Now that we have a solid understanding of data, the business context, and the key concepts like granularity, it's time to take the next step. Let's import this data into Tableau Public and get familiar with the Tableau's interface and cover some more fundamentals of data. This will set the stage for the next section, where we will dive straight into building powerful visualizations from the next video onwards. Importing data into Tableau is super easy. Let's start by opening Tableau Public. Now let's take a quick look at the interface. On the left hand side, you will see multiple options to import a data file. Since our Superstore sales data is in the Excel format, we will use the Microsoft Excel option for importing the file. Tableau also allows us to connect to other file types, including text file, typically CSVs, JSON, PDFs, and much more. This flexibility makes it easy to work with different kinds of dataset. A small homework for you. Take a moment to research and read about difference between Excel files, CSV, which is comma separated values, text files, and JSON. Understanding their structures and key differences is pretty straightforward. And we'll eventually work with these file types extensively in my other data science course, where we will be frequently importing these files in Python. For now, just explore this differentiation to satisfy your curiosity. Cool. Below this, Tableau also provides option to connect with live databases like SQL servers. However, in Tableau Public, this feature is not available. When you start working for a company, they will typically provide a licensed version of Tableau Desktop. This licensed version allows you to securely connect to companies' internal servers, ensuring data confidentiality and seamless integration with enterprise databases. On the right-hand side of Tableau Public, you will find access to various public resources, including datasets, video tutorials, blogs, and Tableau Discover page. We have already covered Tableau Discover in our previous video. Now, to import file, click on Microsoft Excel, then navigate to the folder where Superstore data is stored. In my case, it's in the desktop folder. Select the file, click Open, and wait for a few seconds while Tableau connects to the database. Next, this new window will appear. Let's take a moment to understand what's available here. This section indicates that we are now connected to Superstore sales database file. Below we can see all 3 sheets are available over here. There's also a checkbox for the data interpreter and an option for new union. We'll explore these in the upcoming section, but not right now. On the right hand side, you will notice a large white space. This is where we drag the order sheet to let the Tableau know that we will be using it for building visualization. Go ahead and drag the order sheet onto this space. Notice as soon as we drag order sheet, this large section automatically divides into 3 subsections. The white space is now narrower and contains the sheet we will be working with. Below this, we can see details about dataset structure. It shows we have 20 fields and 999 rows. This matches exactly with what we have in Google Sheet, which is a good sign. The left bottom area provides meta information about the data fields. It shows the data types that Tableau has identified, the field names that will be used for visualizations, table name, which is orders, and the original field names from the orders table as a remote field name. We can rename the columns as needed. For example, let's rename this order ID by adding an underscore between order and ID. Just double click and rename it. Will this change also reflect in the actual Excel file? No, because the remote field name is still intact, which is order ID. If in Tableau we use the order ID, Tableau will use this new renamed column name. That's a relief because it means we are not modifying the source data in any way. Now let's minimize this meta section to explore what's on its right. We can easily toggle between minimizing and maximizing this section by clicking over here. This is exactly the same sales data that I showed you in the Google Sheet. You can easily explore all the columns by sliding the scroll bar below. Now an important detail to observe here is a small icon above the column names. For example, above this order ID, we have a small icon which is this ABC or this calendar icon. This icon represents how Tableau identifies the data type for each field. Let's try to explore these icons in details as they represent Tableau's way of categorizing different data types. First, we have this blue ABC symbol, which indicates that the data in the column is of string or plain text type. This includes values like customer names or product categories such as electronics. Let me show you which columns Tableau has automatically identified as string columns. Here you can see that order ID, shipping mode, customer ID, customer name, segment are identified as string data type. The next major data type is this calendar icon, which represents date. Tableau is highly intelligent and automatically identifies date fields in the dataset. As expected, the order date and ship date are identified as date data type. Similar to the date data type, if a column contains both date and timestamp value, Tableau assigns it a different icon, a calendar with a clock. While a current dataset doesn't include timestamp, you'll likely encounter such data structures later in your career. Be sure to take a note when working with time-based datasets in the future. Typically, financial and banking datasets include transaction timestamps to track the exact date and time of the transaction. The next data type is a number, represented by a green hash symbol. Numbers can be either whole number or decimals. Can you guess which column contains numerical information or numerical values in our dataset? That's right, these are sales, quantity, profit and discount columns, as you can see it over here. Now if I click on this hash symbol in the sales column, it shows that it's a decimal type. While clicking on the quantity field, it shows it's a whole number, which makes sense since quantities cannot be in decimals. The next data type is a Boolean data type, which contains only two possible values, which is true or false. For example, if I create a new column or a calculated field called is profit positive, this column have only two unique values, which is either true if profit is greater than 0 or false if profit is less than or equals to 0. So this is how we define a Boolean data type. And if a column contains only true and false values, Tableau will identify it as a Boolean data type. In our dataset, we don't have any field which is by default a Boolean data type. And lastly, we have an interesting data type that enables us to build map-based visualizations in Tableau. It's called the geographical data type and is represented by a globe icon. Can you guess which fields in a dataset have been identified as geographical data types by Tableau? Let's explore. Fields like country, state, city, and even the postal code have been automatically recognized as geographical data types. Now, the million-dollar question. Why does the Tableau classify fields into different data types? Well, it's not just Tableau. Most tools, programming languages, or softwares we'll encounter in our data science journey do this. The key reason is that it allows for efficient and optimized operations. For example, in Tableau, identifying a field as date enables the software to seamlessly apply date functions, such as extracting the year or month without any issues. This classification ensures that each field is handled appropriately for analysis and visualization. These concepts will make more sense as you start learning SQL and Python, where data types play a crucial role in handling and manipulating data efficiently. But for now, let's stay focused on Tableau and continue exploring its capabilities. Now let's do a small exercise. What if you manually want to change the data type? No problem, changing the data type in Tableau is super easy. For example, if I want to change the postal code to a simple integer number for whatever reason, I can simply click on the globe icon above the postal code field. Even though it's already a whole number, Tableau recognizes it as a zip code under the geographic role. To remove this classification, I can select none from this list, and this postal code will now be treated as a standard whole number without any geographic role. Notice that the globe icon has disappeared and is replaced by a simple hash symbol, indicating that the field is now treated as a number. But let's change it back to the zip code. I don't want to make Tableau angry for no reason. Now that everything is set, it's time to step into the main arena where the magic happens. At the bottom, you will find Sheet 1 highlighted in orange. Click on it and we are now inside the Tableau's workspace, where we will bring data to life with visualizations. I can go back again to the data source by clicking on the data source. But let's go back to the Sheet 1 again. Once in the sheet, the first thing you should notice in this sheet is the left-hand side panel. This is called Data Pane. It contains all the fields from our dataset. And this large white space in the center is our visualization canvas, where we will build all charts, graphs, and insights. We'll dive into the rest of the interface soon as we start building visuals. But for now, let's focus on a few key things in the data pane. Remember how we renamed the order ID field by adding an underscore between order and ID? Well, we can rename it again right here itself. Simply right-click on the order ID field and select Rename. Let me remove this underscore that I previously inserted and hit enter. Notice that apart from the field present in our dataset, we have few more fields which are in italics. We don't need to worry about them right now. These are auto-generated fields by Tableau, and later in the course we will explore how to use them effectively in our visualizations. One more adjustment I like to make is reordering the field. By default, Tableau arranges field alphabetically, and this is not the order that we have seen in the dataset. But we can change it back as per the data source for better consistency. To do this, simply click on the drop down in the data pane and select Data Source Order. And you see all the fields are now sorted in the original manner. Much better, right? Now it's time for the last yet another important part of the video, which is to understand this horizontal separation in the data pane. Notice how fields at the top are blue in color, while the fields at the bottom of this separation are green in color. This is not just for aesthetics. There's a fundamental difference between them. Let's break it down and learn what does this means. Basically, in Tableau's lingo, the blue colored fields at the top are called dimensions, while the green color fields at the bottom are called measures. Understanding this distinction is crucial because it affects how Tableau treats data in visualization. Let's explore this further. Before diving into dimensions and measures in Tableau, let's first understand the general types of data in data science. Data is typically classified into two categories. First is categorical dataset, which represents qualitative information about a variable, and second is numerical dataset, which represents quantitative information about a variable. For example, consider the following data fields from the Superstore dataset, which are gender, state, and ship mode, and also sales, profit, and quantity. Here, gender, state, and ship mode falls into categorical features as they describe qualitative attributes rather than a numerical value. They help us group data into different categories. For example, gender can be male or female or others, while we can have multiple names for the state variable. And lastly, the ship mode shows different shipping methods like standard class, second class, or first class. And since these fields describe what something is rather than measuring it, Tableau classify them as dimensions. And in Tableau, the dimensions are displayed in blue color. Now, after understanding why dimensions are blue in color, I highly encourage you to pause for a moment and think about why these fields are classified as dimensions. Go through them one by one and try to understand the logic behind it. This small exercise will help you build a strong intuition for working with data in Tableau. Now let's move on to the next set of variables. Here, sales, profit, and quantity are classified as numerical variables. Since these fields measure something like revenue, earnings, or product count, Tableau automatically classifies them as measures. That's why they appear green in color in the data pane, indicating they are quantitative and can be used for calculations like sum, average, or percentage change. I hope the distinction between dimensions and measures is now super clear to you. Now let's take one step further and classify categorical and numerical data in more depth. This will help you understand the nature of the data better. If you look at categorical features like gender and state, you will notice that we cannot assign a meaningful ranking to them. One gender isn't higher than another, right? And states don't have an inherent order. Whenever categorical features have no ranking or hierarchy, we call them nominal variables. A few more examples of nominal variables include stationery type, for example, pen, eraser, notebook, and the animal type, which could be dog, cat, and elephant. You cannot rank one animal over another without any context. That's why they are called nominal features. On the other hand, if there is inherent meaningful order or ranking, we call it as an ordinal variable. Here the shipping mode is an ordinal variable because we can clearly rank and tell that the same day delivery is better than 2-day delivery, right? Another example of an ordinal variable could be the customer feedback or ratings. For example, a very dissatisfied rating could be ranked lowest, while very satisfied category can be ranked highest automatically. Also within numerical features, we can easily classify them into continuous and discrete variables. For example, here sales and profit are continuous features because they can take any value within a range including decimals. A product sale value could be in decimals such as $105.75 or $999.99. It is not just limited to whole numbers. Similarly, a profit can be $52.38 or even minus $12.50. The negative profit value indicates losses. Another example of continuous variable is height of a person or a temperature measurement. Both are recorded in decimals. On the other hand, some numerical variables can only take whole numbers, meaning they cannot have decimal values. They are called discrete variables. For example, the quantity variable, which represents the number of products sold, cannot be in decimals. You can sell 3 or 10 items, but not 3.5. Or the variable number of orders. We can have 5 or 50 orders, but not 5.8 orders. Similarly, a population size, which is again a whole number figure, is also a discrete variable. That's it for this video. We have covered a lot of fundamental concepts. Let's give a quick recap what we have learned so far. We started by learning multiple ways of importing sales data into Google Sheets and getting acquainted with the Google Sheets interface. Then we learned the essential terms like datasets, observations, variables, and the significance in the analytics. After that, we started understanding sales data and breakdown of how this data is structured and organized. And on the basis of this sales data, we explored major business expectations where we identified business needs and mapping key variables for actionable insights. Then we explored the concepts of data granularity. Here we understood how level of detail in data impact aggregation analysis and insights. We then imported data into Tableau and familiarized with basic technical stuff of Tableau's interface. And finally, we discussed Tableau's data types and difference between dimensions and measures by understanding categorical and numerical variables. Cool, let's meet in the next section where from the very first video, we start creating visuals and technically understanding the process of how data is aggregated to create a chart in Excel and Tableau.